All right, welcome back. So now we're going to go over the electronics, and I'm going to take you through how to wire everything up, and then we're going to program our design with Arduino. Okay, so if you look right here, we've got a couple of components. We've got the Arduino. So basically, this is a microcontroller. You can think of this as the brain of whatever project we're working on. All our components are going to talk to this, and this is going to tell our components what to do. Any component, whether it's a sensor, a little LED light, anything, will talk to this, and this is what we program to tell all of our components what to do. This is the USB port. It's going to plug directly into the computer, and we'll be able to program the board using C code. Okay. Anything else on the Arduino that we should know? This is a power jack that you can power through. I think your kit comes with a battery that you can power this through. I usually power it through the USB port. Just to explain the ports a little bit. So on this side, you'll see it says digital PWM. That's mostly the ports that you're going to be using, where it says you're mostly going to be using 2 to 12. 0 and 1 is something different. We're not going to cover in this lesson. And then we're also going to use on this side, if you see, it says power. So ground, you get 2 ground ports, you get a 5-volt port. You get 2 5-volt ports, sorry. And if you give power to the Arduino, then you could take power out from this and power other components, which is what we're going to do. And then this is also analog ports, but we're not going to use those today. So that's the gist of the Arduino. So now let's talk about how to wire up our LED. This is an LED, it's just a light, right? The longer leg is the anode, and it's the positive end. So that's all you need to know. Just remember the longer leg, positive. The shorter end is the cathode, and it's negative. This is the component we're working with. And then this is a breadboard. So this is a super useful tool. And basically all it does is it's great for prototyping. So if you look here, this is usually how I use it. So you see these top rows that say plus minus, plus minus. This is where I distribute power. So anything in a circuit is going to have a positive end and a negative end. So usually the negative end is ground, and I denote it by using black wires. And the positive end, I'll use red wires. So basically anything along this path. So let's say I plug. I'm not gonna put it into the, or I could put it into the Arduino. One sec. Boom. Okay, so we're plugging the red wire into 5 volts ground, so it's getting plus 5 volts from the Arduino. And then the black wire is going to go to ground, so it's getting negative 5 volts from the Arduino. And these railings, so basically the red wire is going to the plus, the black wire is going to the negative railing. So basically what happens now is anything that gets plugged in on these horizontal railings will receive the same amount of power. So if I plug this yellow wire into this end, it's in the same row or column as the red wire, so it gets plus 5 volts. If I plug the yellow wire into this anywhere on this horizontal end, it'll get minus 5 volts. It'll get the ground power from the Arduino. Okay, so those are the top railings. Now it's the opposite. The opposite is true for the other ports, basically, that you have on the breadboard. So if I plug something in here and I want let's say I'm plugging the LED here, right? Let's say I want the yellow wire to get the same electrical signal as this prong. If I plug it in here, if these are in the same vertical row, hopefully you can see it here. So the yellow wire is in the same vertical row as this leg of the LED. So they'll get the same electrical signal. All you have to know basically is in the top railings where it says plus minus, use those for power, and anything horizontally in the same row will get the same electrical signal. And then anywhere else, it's the opposite. Anything in the same vertical row will get the same electrical signal. So just a little bit about your components, and now we're gonna build the actual circuit. Another thing to note for this is that every electrical component, for the most part, has its own resistance. But if you use these LEDs from the Arduino kit, they won't have their own resistance, and you have to add in a resistor. If you run power directly to the LED, let's say, so the longer leg gets plus 5 volts, then shorter leg gets minus 5 volts. This thing is going to burn up and break quickly. So basically, you just need a small resistor. There's like calculators online to tell you, what light should get what resistor. I just plug in any resistor for the most part. The higher the resistance, the dimmer the light is going to get, because you're taking away current from the LED, right? I just grabbed any resistor out of my Arduino kit. So let's show you how to wire this thing up. LED is pretty simple. It's only got 2 prongs, like we said before. The longer end is the positive end, and the shorter end is the negative. So I'm just going to pick any 2 slots here on my breadboard. Okay, so we said the shorter end is on the right here. So we got to plug in, the shorter end is the negative end. So in the same vertical column, I'm going to plug in a black wire, and that's going to run into ground on my Arduino. So as a general rule, also, I'll use black wire. I already said I'll use black wires for negative, and I'll use red wires for positive power. And then if I need to run like an actual digital signal, I'll use yellow or orange wires. So here's the thing. So we still have to add in our resistor. And if we wanted to just always have this thing always be on, we could, well, first let's add in the resistor, right? So the legs on the resistor don't matter. I'm going to plug one leg of the resistor into the same vertical column as the positive LED. See if you can see it. So those are in the same, so the short leg gets the same column as the black wire, and the positive leg gets the same vertical column as the resistor. And then the other leg of the resistor will just go to any random column here. So what I was saying before was, if I always wanted this thing to be on, I could just run a red wire to the same column as the other leg of the resistor, like that, and then plug this in to 5 volts positive power on the Arduino. So what this is going to do is, as soon as the Arduino is powered on, it's going to turn the LED on, and it's always going to be on. But instead of doing that, we can replace the positive power to the Arduino with a signal wire. So this goes in the same column as the other leg of the resistor. And then we can plug it into a digital port Arduino on the Arduino. And based on sending a signal from the Arduino in the code to talk to that port and sending a high or low signal, we'll be able to turn off the Arduino whenever we want. So I'm just going to pick one of the random digital ports here. I'm going to pick 8. It's the first one after the break in these ports. Okay. So to review, all that we've done is we plugged our resistor in. The longer leg is the positive one, and that is on the left here, and the negative one is on the right side. And then the black wire in the same vertical row, the black wire connects to the same vertical row as the shorter leg. And then on the Arduino, it's plugging into ground. And then for the longer leg of the LED, in the same row, it's going to a resistor. And then the resistor jumps to another column. And then in that same column, we're plugging in a yellow signal wire. And we're running the signal wire to one of the digital ports on the Arduino. I chose digital port 8. So now let's jump into the Arduino IDE and show you how to program this thing.